Thank you everybody for joining us today. This is Eco Workshop, as one of the workshops that has been organized within the Eco project. And specifically, this time we are talking about malware. Malwares are very spread in the IT products, generally speaking, and as Wikipedia said, it costed every time to the US state, just for them, 6 billion dollars every year, and they are increasing a lot, like 15% more every year. So the type of malwares are increasing way faster than what we might think. So we decided to talk about them, and specifically to show you 3 prototypes we have developed within this project in order to, let's say, solve the issue of the malware, but from each point of view. Let's say from the point of view of capturing them, analyzing them, and finally reporting them to a user that might not be that so familiar with cybersecurity. So we wanted to have something that could cover the whole spectrum of users. So what we are going to see today are, here is the agenda. We are going to have a first presentation about the whole project, the ECO project that is being financed by EU during the Horizon 2020 project. So it's one of the most important that are running right now. And that is going to be presented by Antonis. After that, we are going to see the meat of this session of today, which is the cyber threat intelligence extractor tool, the malware analysis and intelligence tool, and the final prototype, TQM. So we are going to have the presentation at the beginning, and after we digested all the information, we are going to see the actual demo. So we see how this prototype works. And there is a flow, basically, that is coming from the first prototype to the last one. So the first one is more dedicated to intercept them and capturing basically them. Finally, the second one is going to analyze them, and the last prototype is going to use this information in order to exploit and enrich what the user in the end can see. So as you see, the prototypes, they are not living by themselves, but they can be integrated. And I forgot to mention that those are not the only prototypes we have developed. We have developed 14 prototypes in total, and we have presented so far 6 of them. Those are the last 3 we are going to present, so totally 9. But you can find more information on our webpage, or maybe in order to have a quicker and more, let's say, familiar way of getting information on the YouTube channel and the LinkedIn page, where the videos, like short demos, are presented as well. So actually, I forgot to mention my name. So I'm Emanuele San Sebastian. I'm part of Think and Theory Next Tech. And I think I can let the first speaker present, which is Antonis, unless there are questions, of course. Okay, I see there are no questions so far. So if you want to maybe write me something or ask me something later, here is my email in the end of the presentation. So Emanuele.sansebastiano, etc. And yeah, I leave the stage to Antonis.
Hello. So this is Antonis Vulgaridis from CERT. I am the task leader of task 4.3, and I'm going to give a short overview of ECHO, of the ECHO project, and also of what we are going to see in this workshop cluster 3. So in general, the problem regarding the cybersecurity information that is available in the EU is that it is fragmented, and in order to, let's say, leverage on the full potential of it, we need to find ways to combine things and to move forward with a more detailed and more, let's say, complete view of all the available information. So to avoid this and to be able to tackle with that, EU defined a set of cybersecurity challenges that have been identified and will be and are being tackled all these years and for the upcoming years. And this set of cybersecurity challenges are, first of all, to retain and develop all the essential capacities in order to secure a digital economy throughout EU member states. Also to try and find a way to align the work that is being done through research and then align it with what is being done in the industry. So it is, of course, always welcome to see research improve and move forward, but we have to find ways for industries to follow and catch up from there and evolve all the necessary innovations, all the defined innovations through some more specific solutions and so on and so forth. The third, let's say, challenge identified was to find a way to all these technological advancements to make them available through the digital single market of EU, and of course to overcome the fragmentation of the research and the information available, as I explained earlier, to develop some master relevant cybersecurity technologies from components that are going to be used for IoT ecosystems and self-healing software throughout EU. To develop, of course, these innovative security products and services and find a way to protect the assets, the critical assets and the critical infrastructures against cybersecurity attacks. And all of this will have a, let's say, the final goal is to contribute to the European strategic autonomy compared to other markets, the US, China, and so on and so forth. So that's the cybersecurity challenges the EU is trying to tackle through all these programs and all these research innovatives. So with that, ECHO is trying to find a solution about all these challenges, and as some main objectives, the idea of ECHO is to create a network of cyber research and competence centers with a competence hub in the center. And we are trying not only to provide and create some let's say, innovative cybersecurity solutions, but to create a network of new partner engagement model where a lot of cybersecurity centers can be connected with each other with a competence center with a competence center as a hub. So the ECHO project is quite a big one. It is combined at the beginning from 30 partners, and along the way we also involved 14 new ones. The project started on February 2019 and will last for 4 years, but we are searching of ways to extend, let's say, the impact of it by creating synergies, by involving new partners, and so on and so forth. So we involve 19 nations and 9 industrial sectors. We also identified some technology roadmaps, some multi-sector scenarios, and also some demonstration cases where we actually showcase what we came up with during the activities of the project. So the main concepts and technologies that we produced during the course of this project, and we work during the course of this project, was the eco-governance model, which in principle is a way to manage the direction and the engagement of the current and future partners of the ECO network. Also a multi-sector assessment framework in order to assess all the transversal and intersectoral needs and the R&D roadmaps that we came up with. A cyber skills framework, a training curricula, which is also adopted by the EU and is a reference model that actually provides cyber skills framework for trainees, a security certification scheme that is trying to, let's say, certify all the security needs within EU. A federated cyber range, which in principle is a platform that connects cyber ranges from multiple sectors and multiple, let's say, multiple providers in order to provide an advanced simulation environment that supports training, R&D, certification, and so on and so forth, and an eco early warning system, which is a way to share information, critical information between connected tenants all across EU. We also identified some technology roadmaps, which in principle are a way the EU wants to envision the cybersecurity challenges and how we are going to tackle them, not only for these 3-4 years, but also in let's say a 10 years duration, so until 2030. And we identified 6 cybersecurity technology roadmaps for the ECO early warning system, the ECO federated cyber range, 2 additional technology roadmaps driven from from relevant and important cybersecurity challenges, and also a couple of technology roadmaps related with some eco prototypes that we developed along the way. To identify these technology roadmaps, we first had to start and identify the technical cybersecurity challenges that are more critical and more important for, let's say, the last period of time. And we examined more than 140 reports from all over the cybersecurity spectrum. We identified 83 technical cybersecurity challenges, and based on these cybersecurity challenges, we identified also 14 prototype tools and also 2 new technology innovation roadmaps that we work on during the course of the project. Some of these prototype tools are going to be also presented today here for the workshop. So the other asset that we also focused on developing was the intersector prototype tools. As I said earlier, we identified those based on the most pressing cybersecurity challenges, and we also wanted to cover as much of the priority and critical sectors as possible. And the overall goal was to provide some innovative solutions based on state-of-the-art technologies and methodologies, leverage some known technologies, but also provide some new methodologies, machine learning related, and so on and so forth. And the ultimate goal was to increase cybersecurity awareness through workshops, through demonstrations, and so on and so forth. The initial, let's say, the pool of prototypes that were selected were 14 and is covering multi-domains. As you can see in this graphic, there are some prototypes that are covering the attack side of the cybersecurity spectrum, some of the prototypes that are covering the defense side of the spectrum, the blue team, and also some that can be characterized as purple team, which is actually the ones that are sharing information during an attack, during the defense side, and so on and so forth. We are also covering 4 priority areas: the maritime sector, the healthcare, the energy, and the space sector. And we also have quite a lot of prototypes that can potentially cover multiple sectors, which are more transversal. Some screenshots from the UIs from the red teaming prototypes can be seen here, the purple teaming here, and the blue teaming here. But of course, more of that and the more technical details you will see during the workshop, and you also saw during the previous 2 workshops that we made some months ago. Here is also the more explained list of the prototypes and what tools and cybersecurity fields are covered, and how many challenges each one of them is addressed. We had some prototypes that were developed from scratch, so there were ideas created inside the course of the project, and we also had some more mature that we actually find some ways to improve and adapt in order to get them, let's say, connected and integrated in more complicated scenarios. So for these prototypes, we identified a way not only to create them and use them, but to also showcase how they are being used in a more, let's say, complicated scenarios. So for that, we integrate some of them in the demonstration cases, the echo demonstration cases. So demo case number 4 and demo case number 5 had the, let's say, the objective to showcase the capabilities not only of the prototypes but also how they are being connected to other echo main assets, the EFCR and the cyber skills framework. And by doing that, we also had some thorough testing of these prototypes through these extended scenarios, and of course this helped to continuously build and improve upon these prototypes. And of course the demonstration workshops, which is actually the goal of today's workshop, were some workshops that identified in order to not only showcase the use of the prototypes as standalone tools, but also to integrate some of them, the most relevant and suitable ones, in some more complicated storylines. And we already had, as Manuela said, 2 of these workshops some months ago, and today is the 3rd workshop that we identified. The idea behind that is to not only test and showcase the full functionality of the prototypes, but also to get feedback from you guys joining these workshops in order to help us improve and adapt the development phase of the prototypes to the needs and the feedback that you provide. We also had some means of dissemination for these prototypes, so you can find them all in ECHO's website, where you can see some short descriptions, some teaser demos, some more technical demos, and where we categorize them based on the cybersecurity, let's say, fields that they cover. Of course, all of them are also available through YouTube and our YouTube channel. We also have some active services where you can actually find the ECHO Daily Bulletin, and which is in principle the newsletter of ECHO, and also some critical news, cybersecurity related news that we collect from thousands of sources, and we publish material there really regularly, so it's a good thing to check. And we are trying, of course, to increase the level of engagement. So we want new partners. Of course, we already identified 14 new partners, and there is a way to get in touch with us and join, let's say, the ECHO Club and be a participant of ECHO. And that's it, more or less. Here are also the links where you can find us and let's say discuss your potential involvement and find more about the technologies that we developed and what we are working on and what we will be working on the next, let's say, period of time. So that's it. If you have any questions, I'm happy to ask.
Oh, thank you very much, Antonis. We already have a question that popped up in the chat before, and of course you were presenting, so you couldn't see it. And so Sophia asked how the partners can be involved in the eco networks, and specifically if there are requirements, which one are?
So there is a way to join. There are some ways to join the eco network. As you can see in the presentation, there are several, let's say, communication links through social and so on, where you can find us and discuss more with the eco. The eco, let's say, partners and the governance of all of it. There are several ways how you can join. So there is the Eco Club, the Eco Participant, and the Eco Partner. But for more details, I would suggest to directly, let's say, send an email or send us a message through the social, and we can discuss how exactly you can join either as a participant or as a full-grown member of the Eco Network. So please don't hesitate to send an email directly, and we will apply with specifics. The requirements, we will also discuss them through emails, because I don't have a specific list right now. And but please don't hesitate to hit us up with an email, and we can discuss further.
Okay, thank you very much. I don't know if there are other questions, so just wait a few seconds. Okay, I don't see any raised hands. Before leaving the stage to Notice for the first prototype, I want to stress two things that Notice already mentioned that is important to remark. So first is the fact that the EU is financing those projects in order to not just producing assets, but also to create networks. So as Antonis said, it's very important the feedback we are going to receive from you. Specifically, we are going to pose a few questions during the presentations. They are anonymous and they are online, so don't be scared. No one is going to track you, and it's very important that we understand if everything was clear and what's your opinion about something. And at the end of of today, we are going to share with you a survey, and hopefully you are going to reply to it. It's about 15 minutes, and that's actually very important, because we need to know if the products we are developing are interesting, or if you think there's something that we must improve, and or if something is useless, because maybe also we are thinking in a wrong direction. Hopefully not, but it might be. So yes, that's it. Okay, and another thing that the Notice again mentioned, but I would like to highlight again, is the fact that during the ECO we have produced many things. It was a very long journey, around 3 years. It is going to end in January, February. We are going to have some events left that maybe you can join in the future. And basically, alongside the prototypes, we have created other two, let's say, frameworks more than the products. That is the federated sample ranges and the early warning system. The prototypes are supposed to be linked with those frameworks. But there were other workshops related to those frameworks specifically. So without talking about the IT products inside, but more about the frameworks that has been done in the past, and the videos are on YouTube. So if you are curious to see what we are talking about, you can see them in the YouTube channel, and I guess in LinkedIn as well, or anyway on our social medias. In the prototypes that we show today are mostly related to the early warning system, because they are more oriented to give a feedback to the user, and so that I mean, to give warnings actually to the user, so that he can or she can take some decision, or anyway use those information somehow. Okay. I'm done. I'm sorry if I'm speaking a lot. So I would leave the stage to Notice.
Hi, everyone. Thank you for joining today's workshop. My name is Notis Megidis. I am a research associate at Center for Research and Technology Hellas, or CERT. And today I will be presenting you a tool that we developed as part of Task 4.3 in ECHO, as Antonis mentioned earlier, which is called CTI Extractor tool. So before moving on, just a few words regarding the rationale behind the development of the specific tool. The rationale is actually twofold. One is that as technology evolves, cyber attacks progressively become more and more sophisticated and innovative. So actually, for an organization to repel or mitigate an upcoming attack, cyber threat intelligence, or CDI as we will call it for short, plays a decisive role through the collection, classification, and analysis of knowledge about these cyber threat attacks. This gives the defenders the upper hand in order to repel each intrusion they face. And with each intrusion and with each attack, this knowledge is further enriched and allows us to have access to accurate and comprehensive CTI. The second motivation behind the development of our tool is what was mentioned earlier, is that during the ECHO project, the course of the ECHO project, we were able to identify some challenges. And these challenges, we try to address as many challenges as possible with the development, not just the CTI Extractor tool, but all prototype tools that were developed within the ECHO. So for CTI specifically, CTI Extractor tool specifically, some of the challenges that we tried to address were, we can categorize them into two separate categories. There are some main challenges, which the first one is the lack of dedicated tools to manage the cyber threats. The second one is the actual attribution of the cyber attacks. The third one is the anomalous events, or events that are of unknown origin, or they are too confiscated, and we lose the origin within the complex systems. Another main challenge that we try to address with the tool is the large amount of false positive in the detection of anomalies, attacks, but also intrusion attempts. There is also the unauthorized access, which was also identified as a major cybersecurity challenge. And finally, the lack of proper raw data collection tools. Apart from these main challenges, there are some other possible challenges, because we try to do our tool, to develop our tool into as modular as possible, in order to be able to accommodate in the future additional threats or additional challenges. So some other possible challenges is CMS hacking, SQL injection attacks, JavaScript injection attacks, but also attacks on remote desktop protocol services, and also remote command execution services. And last but not least, also DLL injections, which, however, it's for the time being is a bit outside the scope of our tool, because it requires some low-level monitoring of the actual system. So some of the capabilities. Actually, the CTI extractor is a tool that aims at the extraction, analysis, and consequent correlation of CTI from internal sources. The monitor internal sources are using the settings that is provided within each monitor system's configuration. After the collection of the logs, the tool aggregates and processes these logs and then groups them into sessions. We will get a little bit into more detail in the next slides. The next step is to extract information related to these security events. And as a first step is to use a signature-based approach. This signature-based is, let's say, quite naive way, but it's proven to be quite efficient during the past. It's actually signatures that are based on regular expressed rules. Some of the rules are custom made, some of the rules are predefined, but we also, as a next step of identification and threat alerting system, let's say, we also implemented a machine learning based engine. Another capability of the tool is that it offers a quite intuitive graphical user interface and provides detailed insights of the findings. Also some statistics regarding some key metrics. And finally, it integrates. We created a full integration with external tools. We will see which are the tools later on, but what we actually try to achieve with this integration is to further enrich our collected CTI and further improve the investigative capabilities of an analyst. So a high-level architecture of our tool. We can distinguish them into three basic steps. The first one is the data collection and extraction part. This is accomplished with two main platforms. One is the actual data collection, gathering, and management platform, which in our case we used the Wazoo platform. And the second one is the data collection, which we did by utilizing honeypots. Our basic honeypot was Dionia, which for those of you who were not familiar, is a low interaction generic honeypot. It offers a quite broad attack surface. I mean, it offers supports a lot of protocols like FTP, Telnet, DNS, Mongo, and so on and so forth. And what is the most interesting, at least, feature of Dionia, and what we are going actually to present also today, is that we use Dionia as a honeypot to collect malware samples, actually payloads from malicious actors and attackers. The second part is the data analysis and the threat detection, which, as mentioned earlier, we use the rule-based approach, some built-in Wazoo rules, but also custom-made rules and enhancement, and also the machine learning-based approach we previously mentioned. And finally is the correlation of the CTI. On the picture, you can see a high-level design of the architecture. We also offer sticks export of the CTI in sticks format, after, of course, validating first that it follows the sticks format rules. And as we said, it's quite modular. For the time being, we are monitoring two systems, one web server and the Dionia honeypot, but we can include in the future SQL servers and database servers of our taste. A little more into detail. First of all is the processing of the logs. For this purpose, we developed custom wrappers and decoders because honeypots and actually every native service logs follow different formats, so we have to build wrappers and decoders to actually decode the log itself. So we use the pre-processing to homogenize and get this information ready for Wazoo. Secondly, is we created a session manager. We create sessions according to some internal rules. For example, one of that rule is that if we receive consecutive requests from the same IP in a moving time window of 30 minutes, we consider this to be a session, which further improves our ability to investigate events, because we are able to group a lot of different events into sessions. And we extract some values features actually for the machine learning creation of the dataset that we used. The third step is the visualization. One sample of our dashboard, you can see it in the picture on the right side of the slide. We are going to go into more detail in the actual presentation or demonstration of the tool in the second part of the workshop. And finally, the integration with tools like Spiderfoot, which offers an additional 150 analyzers. So we have access to send our indicators of compromise to external analyzers through Spiderfoot. And also the malware analysis and intelligence tool that's also going to be demonstrated today. And this concludes the short presentation of CTI extractor tool. I will be happy to answer your questions if you have any.
Okay, I don't see questions. I guess your presentation was very clear, and probably later during the demonstration, some question will pop up. So, Chartai, if you want, the stage is yours then.
Sure. Hello. My name is Chartai. Here is Yannis. We are together in the same room, so you have to see him as well. Let me share my screen. As Notice said, the unavoidable question. Can you see my screen?
Yes. Yes, we can see that.
Okay, perfect. Perfect. So I'm going to present you malware analysis and intelligence toolkit. And for this, first, let's start with the name. The name is basically a pun. It's a malware analysis and intelligence toolkit, but we call it MATE because it's an analyst's mate. So it has some tools, techniques, and methodologies which helps the analyst conduct malware analysis and collect intelligence, cyber threat intelligence about malware. This was the main idea when we were started developing this tool. The challenges, targeted cybersecurity challenges, were when we started. It was malware, of course, malware anti-analysis techniques, ransomware, lack of adequate cyber risk mitigation frameworks. Also, the risk can be calculated through collection of the intelligence, and this tool collects intelligence, and for that reason, it helps the cyber risk mitigation frameworks. And also, one of the main problems, and I think holy grail of cyber threat intelligence analysts, is the attribution of a cyber attack. And while this MATE tool is not replacing an analyst and finding the attribution, it still provides a big step forward for this problem. So how did we design MATE? First of all, we added state-of-the-art malware analyzers, static and dynamic, which will be demonstrated today. And we have integrated malware databases to our system. And also we have integrated the CTI extractor, the tool that Notice presented. We have integrated that. And also we have seamless integration with many cyber threat intelligence sources, such as VirusTotal API, LInvolve OTX, Farsight Security, Security Trails API, Threat Intelligence Platform API, IPUs, and couple of others that will be demonstrated today. This tool is capable of reporting the reports, the collected reports, collected intelligence and produced analysis reports to early warning system. It exports JSON data mainly, and it has a graphical user interface, which will be demonstrated. Excuse me. So let's start with the static and dynamic analysis. If just to give you the basic definitions and what we are trying to do. With the static analysis, we don't run the malware, but we analyze the executable file, and this is an easier methodology to conduct. It reveals many useful information, such as the entropy calculation of the executable file. Entropy is important because we are checking the encrypted sections or packed sections or obfuscated sections using the entropy value. It of course calculates the MD5, SHA-1, SHA-256. It extracts textual features, strings. It extracts import hash, import fuzzy hash from APIs, and also it is capable of extracting metadata from Office documents as well, and also it cross-checks the collected data with the open source intelligence. With the dynamic analysis, we run the malware and we collect the behavioral features of the malicious file, where we used Kuko sandbox for made. And also we from this sandbox, we collect network monitoring, we collect disk and function call usage, we collect DLL injections, we collect process injections, we analyze the memory, we dump the memory from the process, and then analyze it for features and malicious files. We understand if it has a packing, obfuscation, encryption, that sort of thing. And is there a question? Sorry.
I'll follow them.
Okay, all right. Let me continue then. And also, if the malicious file has any dropper functionalities, then we also analyze that too. For the cyber threat intelligence capabilities, as mentioned, we have the cyber attribution. We collect tactics, techniques, and procedures from attack framework, and we represent it on attack framework. I'll show you today. We collect intelligence tags tagged by the analyst. We collect information for malware lineage and which malware families does this malicious file belong to. We also collect detection dates, and chronological analysis. We collect all the detections from all the possible engines that we have in order to understand if this malicious file that is under investigation was part of a malware attack campaign or a part of a bigger attack campaign or not. So to understand that, we collect the dates as well. To show you what we have also as a navigator, this is just a screenshot that I will demonstrate today. We have attack framework collection, and then we map the malicious tactics, techniques, and procedures onto the attack navigator. We also collect URL, domain, and IP intelligence because when you do the analysis, in most cases you find out that this malicious file is having a connection with CNC, command and control server, or an IP address, a URL. So we collect these, and there's two modules for URL, domain, and IP intelligence, where you can analyze these URLs and IPs. Also, we have the as the one of the best features of this tool, of course, that it has connection to the Echo early warning system, and it publishes the information instantly, almost instantly, to the Echo early warning system, which is considered to be the biggest intelligence capability. Let's have a look at the structure a little bit. Without going into too much detail, what we have is we have a dispatcher, which is the main structure that we are dealing with, which is the main interface. We have analysis packages, we have reporting packages, and we have also CTI generators collecting information from all these. And also we have OSINT Investigator and Chrono CTI Attack Mapper and that tools, but these are the main packages that what you see on this slide. On top of this, this tool has an API endpoint where it can be accessed. The engine, the backend can be accessed and used with an API where all these functions are given. And this is also this Mate tool is open source tool, and also the API endpoints are open. I will share the links by the end of the my presentation. Yes.
Nice comment here from Andrea.
Of course.
Presentation.
Of course. Yes. I know that in the screenshot the details might not you might not be able to see them, but in any case I will share the endpoint URL so you can investigate it and you can have a look from there as well. And what we see here in this screenshot is the early warning system connection where we have the malware report uploaded to the early warning system, and also the reports, the static, dynamic, and CTI reports are given as an attachment in the JSON file. And also we have a little, for quick information, little facet, as we call them in early warning system, where you see the APT attribution, the Intel tags, and the detection dates given in here. And this is just a template report, and I will show this report in the demonstration. And this is the URL. This is the screenshot of the GitHub page of Mate. You can find relevant information and the information that I'm presenting here now. And it's all open source, so you can download and use it for your own security operations center capabilities, along with early warning system, of course. And thank you very much. Is there any question? And this is my contact details. You can send an email about Mate or any other questions if not now, or if you want to first go through the open source GitHub page and the API endpoint and then send me. Here is my email. But if there is any questions, I can take it now.
Okay.
Yes.
So thank you very much for the presentation.
Thanks.
I don't see any raised hands, so I guess no question are coming now.
Good morning. My name is Ewa Konieczna. So I will show you another prototype we have developed within the ECHO project that focuses on assessing the information shared by other companies, and in particular information shared via the intelligence sharing platforms. So to start with, we need to think about a little bit about what are the challenges in assessing cybersecurity threat intelligence. And later we will try to think about the ways how to solve these challenges. So those of you who work with intelligence sharing platforms, I'm sure that you have noticed that one problem that is very visible is the data quality. So it is very subjective what should be defined as the quality of the information shared, how it should be measured, if it even can be measured, and which CTI is actionable. So according to the ENISA report, actionable information for security incident response should meet the criteria to support decision makers, which means that the criteria defined by them are the accuracy, relevance, timeliness, completeness, and ingestibility. Again, this is very good point, but it's not that easy to assess, especially objectively, if this information meets this criteria. Another big problem that information sharing platforms are facing is the trust. So it must be trust in the reliability of the information source, or it can be just the trust in the expertise of the organization sharing the data. one important question that we were asking ourselves is, can trust be determined using an objective automated mechanisms, or is it purely really based on subjective experience of each expert or each organization? It can be mandated based on recommendation, or it can be based on purely just subjective experience. One more thing, actually quite important challenge that based on our research operations analysts are facing is the amount of data that can't be just processed in time without having their value decreased. So there is a data overload. Not all the data available or not the intelligence available is truly helpful. And what happens with the data overload is that some information that actually is actionable could be overlooked. On the graph in here, you can see the general outline of eco warning system. It solves to some extent some of those situations. It helps companies to navigate through with whom to share the intelligence and how to do it, how to select the groups of companies with whom to share the intelligence. There's options and selections of which parts of the information should remain private, which ones should be public. And this customization might help a little bit to some extent. So we were trying to build on it. The objectives of our prototype, and we called it trust and quality metrics. Prototype is very self-explanatory, the name, was to allow organizations to view automated evaluation of the quality of the information received. Regarding the trust, the objective was to allow organizations to assess whether they can trust the organization sharing the information. Not an easy task at all, but this was our goal. And regarding the threat data overload, the objective was to help organizations to prioritize information they should pay attention to. So we approached the creation of the prototype in 3 steps. So to start with, we conducted the study and state-of-the-art analysis. So actually Bournemouth University, who is also here at the meeting with us, helped us with this research and conducted proper analysis of all the research that has been done so far regarding the topic, and available also tools and capabilities of information sharing platforms. Based on this, we build a prototype to measure trust and quality of the CTI. Some of the aspects were very difficult to measure. Some of those aspects we could measure. You will see later during the demo. And because the calculation is automated and objective, we ran a comparison study between the automated scoring and expert scoring. So we asked a group of experts, there were over 40, just to review the threat intelligence and basically assess its quality. And then we use these results to calibrate the weights and the values of particular metrics. On this slide, you can see the very high level architecture. So you can see the concept of how the prototype works. So it extracts the information, the properties from the EWS, which is our early warning system. It uses current and historical data to compute metrics. So it doesn't only use whatever came in today, but it also uses the record of previous intelligence received from certain organization. And it returns a report explaining what are the results, but also how they were calculated. We thought it's very important for the user to understand, not just see a number, but to understand like how this number was calculated and which particular aspects have the lowest or the highest value. So all this is stored in the database, and in addition, to allow organizations, especially when we have situation of bigger distributed organizations with several branches, we wanted to allow them to share these results among them. or to share their experience with some CTI among them. So for this, we created the reputation service, which basically is a way to exchange information between different instances of our prototype. In here you can see, and I think it's not very clearly visible, but you can see the examples of the report and the calculation ways of calculating the scores. So for the ticket quality score, we use the completeness, extensiveness, and freshness based on the last modified date, because we assume that CTI that still receives some inputs and comments and is being updated shouldn't be considered outdated. For the organization trust score, which is basically trust in the quality of the information the organization is sharing, we are using the previous quality scores of the previous information they shared, and also we consider their sharing activity. And then the reputation score, as I mentioned, is based on the trust scores that were shared by other partners. So to conclude, based on the research, there is no single reliable way to rate the CTI that would suit preferences of all users and industries. This was a very big takeaway we got from the research. It is subjective, obviously, but even though it's subjective, we see the value in helping users with their decision making, especially when it comes to filtering the overload of information they are receiving. So the prototype serves as a proof of concept. It does help the guided decision making. And one important part in here is that metrics and their values, they can be calibrated. So the organization that decides to use it, if this organization prioritizes the newest information or select some other metrics that indicates the most relevant information for them, they can change the weight of this particular value to suit their needs. So we made it adjustable in this way, and we are using it with AWS at the moment. This is how it was tested, but the concept in general, it has potential to be used with other information sharing platforms. And we hope that it will be, and it will help the operations analysts make better decisions and filter information in a better way in the future. One more thing I would like to mention is that we also support the information exchange with other organizations. This is something that was explained in the past, because in the information sharing community, like, cooperation is very important. So if we can share the experience with another organization, this certainly should provide added value. Okay. This is it for the presentation. I have a demo prepared based on the example, specific example related to this workshop and the previous prototypes that were presented. So if you have some questions, you can ask now, or we can discuss in the end of this workshop. Thank you.
Okay, I don't see questions, but actually we have the questions for you guys. You can find it in the chat. And it's a question posed by Eva, and I'm going to show. Okay, some people already replied to the question. So here, so what is, in your opinion, the best way to evaluate the quality of shared cyber threat intelligence? And okay, so just 7 people so far replied. So maybe we're waiting for other people to reply. Maybe the link is not working. Oh no, okay, now it's some other replies are coming. Okay, I see that both combination are what people prefer. Eva, why do you want to place this question? So what's your opinion about that? I mean, you can maybe elaborate a bit over that.
So the replies I'm seeing at the screen, they validate our research. We do realize the helpfulness of user rating, right? So there's a 5-star option, 3-star option, thumbs up. It's very indicative. It is. At the same time, in order to have this user rating, somebody needs to be the first user who goes through it, right? And then we need to create this pool of users that provide several ratings in order for for this score to be somehow objective. So even though user rating is a great way to evaluate the CTI, we still wanted to aid the users, at least at the beginning stage when they are receiving the CTI, at which is new, which is fresh, basically. So in our conclusion, the best would be the combination of both of these methods. So there would be the user rating, at the same time, some type of guided decision making also has a potential to be helpful. So thank you for your answers.
So basically, what people replied is exactly what you had in mind, and you can, let's say, prove again your point. Okay, so Eva also wanted to have, I mean, she prepared another question for you, and I'm going to share with you the new link you can see on the screen, which is what is your opinion the most important when you're evaluating the reliability of cyber threat intelligence? And so you have among the options the authenticity of the source, proven competency of the source, information is confirmed by independent sources. So in this case, we don't have both as a possible reply. Okay, let's wait a bit. So again, maybe meanwhile we are waiting for the replies, Eva, you can elaborate a bit over this question as well.
I do not want to bias the results.
Okay.
So obviously all of those things are important, and there is no option to select all of it because I wanted to see if there is maybe some clear preference, but all of those ideally we should have all of that when receiving CTI.
So basically, I see that the middle option is not the one that is preferred by the audience. So the other tools are the most perfect ones. So I guess we have enough feedbacks, and so now you can share your opinion or your ideas about that.
So I actually see that if we have proven authenticity of the source and information is confirmed by independent sources, then in fact that proves the competency of that original source, right? So basically the middle option is being fulfilled by the other two being met.
Hi everyone again. So this is the main dashboard of the CTI extractor tool. As mentioned, the general idea is to create actually a tool to provide contextual and detailed information about all the security events that happen in a monitor system. So as you can see, the first on the top left side of the screen, we can see the total number of systems that we are currently monitoring, how many of them are also online. Right below that, the user is able to see some additional technical information regarding the monitored systems. More specifically, the host name, its IP address, the operating system that is running in the specified system, and also some hardware details like CPU type and the amount of RAM. Which brings us to the actual investigation of the events, whereas the user has to select a date to check for these events. The analyst is able to use some ranges, some predefined time periods for the events to appear. It can be 24 hours, it can be 27 days, or it can actually be 1 month. It takes a while because my internet connection today is not very fast, and there is a quite large number of events that needs to be retrieved. So apologies for taking some time. Okay. All right. Took a while. So in the middle of the screen, there is a graphical representation of the events, and more specifically, on the left side, we can see the distribution of the sessions, also the distribution of the logs, but also the distribution of the alerts over time. Next to it, there is the type of the protocols related to the attacks, to the events. Also the classification of the events according to the MITRE attack knowledge base. Classification is based on techniques and tactics. And finally, the amount of malicious versus benign events. So this is a statistic that is generated from the machine learning algorithm that I mentioned in our first presentation. At the bottom of the page, there is the event viewer that contains the aggregated and processed logs, and it is grouped either into sessions or either into IPs, depending on what the user wants. It's actually user preference, so it doesn't, whatever suits the taste of the analyst. The tool also has the ability to bring it back to 24 hours just a little bit faster. The tool also gives the ability to map an IP address, the geographic location, and also provides the information on the specific location, such as IP, country of origin, regional information, and the ISP provider of its IP address. What else? Besides the IP geolocation, there is also the integration with Spiderfoot that I mentioned earlier, which allows a user to check an IP address against external IP reputational services like Abuse IBDB, Alien Vault, and many more. And all these services, as I said, Spiderfoot contains a lot of external analyzers. We try to build it into as much of modular way as possible, so the user has the ability to enter his API keys depending on the service or the analyzer that he wants to use, and also enable or disable the services that he wants to send the information to. Let me see. And also for today's actual demonstration and actual meat of the presentation, check once again. Sessions there. Let's try to find a malware sample to demonstrate how a malware sample collected by a honeypot is displayed. this example, you can see that the Ionia captured a sample. Actually, the MD5 hash of the actual sample and also the file name. The scan IP returns some virus total results that considers them to be malicious. This is displayed with the red color. Also here, the flag malicious says that our machine learning engine identified it as a malicious event, as a malicious session. And also there is this flag that says that the actual session contains a malware sample. So by pressing the malware analysis tool, we communicate with the API endpoint provided to us by the Bournemouth University. So we are able to post our malware sample for further analysis to the malware analysis intelligence tool developed by EU. And by pressing send, we can say that malware has been successfully sent for analysis. And this gives us, at this point, we should give the floor to the mate tool in order to demonstrate how the analysis takes place on their end. So this concludes the demonstration, a basic demonstration of the CTI extractor tool. I will be happy to answer any of your questions, of course.
Okay, thank you very much, Notice. It was quick and very precise. Actually, personally, I really like the appearance of the service that I see there. I mean, it's very modern in a sense. Okay, there is a question in the chat by Ricardo Orizio. What is the underlying technology used to share the information between the components? Are there any security requirements on it?
To share the information between the components. Basically, it's an HTTPS endpoint, I think. It's built on SSL. There is also the token, API token provided by BU also. So it's a security token used for the actual API communication. Besides that, probably the Saga type has some additional information regarding the security for the API communication. Is there something that I'm missing?
Notice you explained it actually. We are using basic authentication with a token for now, because this is supposedly what we have here is in a works in a lab environment. That is how we designed this tool, the mate tool at least. So it works in a lab environment. So basic authentication is provided, but not to the extreme. And also SSL certificates are used for the endpoints. Okay. For the moment.
I mean, let's not forget that these are prototype tools developed as prototypes, and they are still in work in progress.
Yeah, Ricardo said thank you. So I guess that your replies were enough. If there are no other questions from the audience, actually, Notice has a question for you. And I'm posting that in the chat, and I'm going to share my screen so that we see the results. Meanwhile, people are replying to that. So cyber threat intelligence can empower us with data about existing or potential threats. What are the main levels of threat intelligence? And here you have 3 options. So tactical intelligence, which is focused on the immediate future, is technical in nature and identifies indicators of compromises. Operational threat intelligence, which is focused on actor profiling to gain a better understanding of adversaries behind attacks. Or in the end, strategic threats intelligence which is focused on information business decision and the processes behind them. I don't know if you Notice want to elaborate a bit more in order to help people to reply on those questions.
Yeah, actually, I would like just to rephrase the question to what is, according to your opinion, the most the most useful type of threat intelligence, because all three of these are considered levels and types of threat intelligence. But let's rephrase the question to what, in your opinion, are the most important one?
Thank you. So I see that the middle one is so far the preferred. Oh, okay, the third one as well as some replies.
The first one also.
Yeah, the first one is reaching the middle one, but the middle one is still on the lead. I really like this interactive way of seeing how people will reply to questions. Like it's like watching, football matches during the weekend. It's basically the same.
Yeah, I agree. It's a nice way of interaction, and also increases the immersiveness of the workshop. It's like more.
Okay, we can say that the third option is not very popular, while the first is getting popular, and the middle one is in the middle one in the end. So what's about you, Notice? What do you have in mind about it?
Actually, there is not a right or wrong answer this question. The first one, the tactical intelligence, as mentioned during the question, is focused more on technical indicators, such as IP addresses, URLs, file hashes, also known malicious domains. It usually is machine readable, and usually is the most easy one to obtain tactical intelligence. In contrary, for example, the second one, the operational threat intelligence, is a bit more difficult because it also has the attribution part, the who, the why, the how. And Chagata explained it very nicely during his presentation about the actual cyber attribution. The last one is, in my opinion at least, is the most difficult one to accomplish because it has a lot of, it does not strictly, it is not regarding only the cyber threat intelligence specifically. It helps also decision making. You need to understand the risks that are posed to an organization by the cyber threat intelligence threats. And it is the hardest one to generate, at least in my opinion. But as mentioned, there's no right and wrong. It's all three questions are perfectly fine. It depends actually from the point of view of the responder.
Yeah, but by the way, I see that the popularity of the third reply, in fact, is lower as you predicted in a sense, or as you think. Okay, so thank you very much, Notice.
Hello again. Can you see my screen? Yeah. Okay, so
Yes.
now what you see on your screen is the user interface of Mate, and it is a browser-based user interface. So what we see here is basically a browser. Some of the analysis, by the way, this is the file that it has been sent to us through CTI extractor, as you can see here. Is my also, if you can see my cursor. So this is the main tool. What we have here is a file submission, static analysis, dynamic analysis, CTI collection, attack navigation, URL intelligence, IP intelligence. I will show you all these right now. So for the static analysis, with this analysis, what we have, as mentioned in the presentation, that we have static information from the executable, such as general information, like which architecture that this malware is based on, address, size, any stack canaries included, when did it compile, and which architecture is being used, little endian, big endian, and so forth. And we have the sections and their entropies, As you can see, we have some encrypted section here. The entropy value is in between 0 and 8. And what you see here is close to 8 means that it is more likely to be random data. And this randomness kind of alerts that this section is encrypted. We have loaded libraries, network operations. Since we have most of the data encrypted, we don't have much here. File hashes, and also all the strings extracted from this malicious file, as you can see. Now, dynamic analysis and CTI collection takes some time. In order to not to make you wait here in this presentation, we have run them a couple of minutes ago, basically. So for the dynamic analysis, what we have here is we noticed that we don't have much coming from the dynamic analysis, but what we have is the software packing is applied for this malicious file from TTPs. For the signatures, again, the binary likely contains encrypted or compressed data. So basically, the dynamic analysis did not couldn't extract the file because this is the case for some malicious files. They understand that they are being analyzed and they don't reveal their true selves. So sometimes we just see that we have Packer only the Packer flag is up. But this is not going to stop us, obviously. So what we did after that is we collected some intelligence about this file. This is in the presentation. There have been resources shoved, and this is collected from these resources. So what we find analyzing this file is that this is a part of an APT attack from the Silver Terrier group. These are all the TTPs that has been collected for this malicious file from attack framework, tactics, techniques, and procedures. As you can see from Elimwald, we have auto start execution, user execution, deobfuscation, local account, and so forth. And it goes on like this: key logging, spear phishing, input capture, process injection. You name it, this malware got it, basically. And for the tags, we noticed that this is part of the Agent Tesla malware, and it's a Trojan or remote access Trojan. Here, these are the tags from Malware Bazaar. These are all the runs from Malware Bazaar coming from any run, unpack me, VMray, and so forth. So these are the runs that has been given, and we noticed that there is a URL also included for command and control. We will run this URL with the URL intelligence. This also takes some time to retrieve, so that's also has been retrieved. But I will show you a couple of the demonstration that will be run like in an instant. So these are the ones that require some time. And next we have the chrono analysis. These are the detections coming from any run when the first seen date for this one is here. For integer, inquest, cape, triage, and all these also dates are given. And also for virus total at the end, we have all the engines detection dates. Basically, they are all showing the same, almost the same date, around same date. So it must be that there must be an attack campaign going on in between 26th of September and 3rd of October, I think. Yes. Here. So for the command and control server, we have run this using the URL analysis tool. This time we are not providing like these tools, sorry, like files. By the way, all these files are coming from the CTI extractor tool. And we are just providing the URLs because we might, as you can see, we might stumble upon some URLs and IPs and we need to run them. So we have here the URL intelligence. We enter this, and what we receive is from VirusTotal, we have one positive for this URL. And there are, of course, many subdomains for Telegram, as you can see. These are just some surrounding peripheral information about the URL that we are dealing with. Since this case is it's a Telegram address, of course we receive lots of information, but not all of them means that these are malicious, obviously. IP address resolutions for this domain is given here. All these IPs are related with this domain. We have whois information and historical whois information for the URL, but since we have Telegram again, we don't have much other than the Telegram's data. First seen dates also here. And these are the historical URL data. And we have related malicious files. This part is important and interesting. So with this URL, from this cyber threat intelligence that is being collected, these files have been found from previous analysts that conducting this URL, which means, and there are a lot of them, which shows that this is also a part of a botnet. As you can see, all these different hashes communicating with the same URL and also downloaded files as well. So it goes on forever. So I'll just pass the related ones. We didn't get anything from Farsight Security for this one. We have DNS records, historical DNS as well, historical SSL as well. As you can see, the previous certificates for this URL are given here. I'm not going to conduct full-on investigation, but just to show you what we are collecting. This is also another historical SSL certificate from another source. And it goes on like this. So this is SSL information is also retrieved. Here, all the certificates the actual certificates also, you can find the certificates itself. And for the URL, Linvolt and Linvolt didn't return anything because probably they blocked it because it's actually the Telegram. So yeah, these are the ones that we have conducted previously. So let's continue with the attack navigation now. So maybe I can show you from the video as well. Give me a second, please. Sometimes it crashes. Let me show you from the video then. Just quickly go through the CTI collection, and after that, you'll see that for the same malware. Pass this part as well. Yes. For the attack navigation, now we select the malicious file, we run it, and then we receive from the attack navigation all the techniques, tactics and procedures retrieved on the attack navigation page. And this is the submission to early warning system demonstration where we select the file, we enter the traffic light protocol, and we enter the priority. Some more information here. And then once we submit, actually I can show you the ticket from here. This is the report that is generated by Mate. As you can see, we have the title, we have the template, we have the distribution traffic light protocol, we have the tags. This is assigned to Yanis again, of course, like all the tickets that I'm sending. And then we have the APT attribution, the same information that has been found and shared immediately. And we have all the analysis attached here. Yes, that concludes the demonstration. From here, Eva will take the floor and show the how the trust and quality will be calculated for this ticket. Any questions?
Thank you very much, Chagai.
No worries.
So I don't see any raised hands. So we are a bit short on time. So I would go directly to the main question that EU Chartai designed for the audience. So you can find it in the chat. And so this is the questions. Which of the following threat intelligence elements do you think is crucial when analyzing a malware? And you have 4 options this time. So attribution of malware, temporal information about the malware, spread of lineage of the malware, and related vulnerabilities. There are actually many other options that are possible, generally speaking, but we decided to group just those 4 in order to, make the choice a bit more easier than placing all the possible options. Okay, I see that related vulnerabilities is one of the favorite ones. Charatai, do you want to elaborate a bit over this question?
Yes. Now that I see that probably in terms of the intelligence related vulnerabilities is one of the main things to prevent the further spread of the malware. So that's why it's selected, and it totally makes sense. But also the understanding of spread and lineage, like if this malicious file belongs to some APT group, or if this file belongs to a particular attack campaign, can be important. We have mentioned attribution. I think attribution is gaining its pace from what I see. And the chronological information or temporal information also equally important as I see. But one of the main things that is crucial is vulnerabilities to prevent further attack. I suppose that's the general opinion coming from you. Any questions about the in the meantime?
Well, so I don't see questions, so I guess we can proceed.
Yes.
So, rushing up to the end, Eva, you are the last player of today, so the stage is yours.
Hello. So I have a recording prepared. So those tickets that Bu shared, we already pre-analyzed them. So I will take exactly 7 minutes. So just let me know in case you cannot hear the sound, or just let me know if the video is okay. I'll play it right now. This video demonstrates the use of TQM prototype for the assessment of cybersecurity threat intelligence received via threat intelligence sharing platform. Our prototype analyzes the information shared via the ECHO early warning system as our preferred information sharing platform. In this concept, companies are assigned to one or several constituencies based on their industry or common interests. The CTI created can be shared with a selected organization or full constituent or several of them. You may ask yourself, why would some company decide not to share the information just with everyone? Well, imagine the concept of constituents being similar to the mailing lists. The company may want to share the information only with their selected partners or may find the threat relevant only for a certain industry, for example, the industry using a specific technology. The reason may also be as simple as the fact that our company has joined the platform or a certain constituent only recently and does not really have the access to the information that was shared earlier. This is the case in our scenario. We are representing the security operations employee of the Portuguese branch of the company called VST. This branch was opened last year and joined the information sharing platform only recently. As you can see in the employee dashboard, the only information received so far was the exchange of intelligence and warnings with their headquarters called VST. At this point, the analyst also receives a ticket called Malware Report by Mate. This organization is in the same constituent as we are, the organization called BU-CERT. You can see with whom the ticket was shared in here. Because the organization is in the same constituent, we can assume that the message is relevant to us, or at least they think so. Now, what would be your reaction if we received several of those messages in parallel from various sources? Which one would you prioritize first? The most updated one? The most relevant one? The most updated one seems like a logical choice. The last modified date, but also extensiveness of the ticket are among the metrics used by our prototype to calculate the quality of the ticket. In case of an overload of messages, you could add a column displaying their score, the score of the tickets, and sort your dashboard accordingly, helping you to prioritize which one to pay attention to first. In the quality report, you can see that the score originally calculated for the malware report by Mate, the ticket called like this, is 66. And it is not the highest, but it is fairly good enough. It is just the first experience we have with the company, and we are not really sure what experience they have, what expertise they have, and how seriously should we treat the information shared by them. As per the settings selected by us, the scoring system of the TQM prototype is dynamic. This means that the additional information or contributions by BU or by BU's collaborators further increase the quality score of the ticket. Therefore, they highlight as the usefulness of the source of information. Additional updates might include additional references, links to wiki pages, or additional comments and information provided. In order to find out more, our security operations analyst checks BU's reputation. As you remember from the presentation, the reputation is based on trust scores that were shared by other partners of the constituency, in this case by VST headquarters. As you can see, BU's reputation is higher than the original trust score assessed by us. Now, let's take a look at the situation from the point of view of the headquarters. This organization has received an additional ticket from BU that was of a higher quality. You can see the additional malware ticket in here and its quality score in here. This also shows that BU's proven track record of sharing comprehensive tickets referring to additional sources of information has earned them a higher trust score in the point of view of VST headquarters. look back at the Portuguese point of view, this number corresponds with the BU's reputation score they received. It's also 60. This information will make the SOC analyst trust the quality of the information provided by BU CERT more and proves the good relationship and experience with the organization sharing this information. On our example, we had only 2 tickets, but in the real life scenario, there will be likely many, many more. So in this basic example, you can see that thanks to the cooperation with other organizations, we may still receive the information about someone's trust in the ticket creator, in this case, the reputation of their tickets. This demo was focused on the prototype assessing the CTI, but it is also worth pointing out how useful the EWS's multi-tenant architecture is to distributed or multinational organizations who can now easily share their incident details, their knowledge, or warnings among their offices.
I would like to mention again the fact that there are many events that we are planning to have in the next month. Specifically, we are right now projecting another demo case, the demo case 7. Maybe if you recall the presentation that Antonis did at the beginning, he mentioned demo case 4 and 5. The session of prototypes is the group of demo case 6, while demo case 7 is going to be a sort of great closing event in which all the or most of the parts developed within Eco project will be shown to the audience. So we don't have a date for today, but if you subscribe to the newsletter, you will see when this event will occur. It is going to be, I mean, the final one, so it's supposed to be great in a sense. And that's it. Thank you very much for attending today.